Yes, hi. So welcome to West Coast Machine Learning. And before we start formally on the topic of uh, DeepSeek, I'm forgetting the name. uh, Let me just quickly share how many providers have in the last. It got announced on 25th or something like that, right before the weekend, or maybe a few days before the weekend. But I just wanted to quickly share how many providers are already supporting it. So I created a quick list, which is not complete, by the way, asking ChatGPT search, tell me the list of all the providers who are using DeepSeek. Amazon just announced. So this
So
is,
ChatGPT actually gave you information about DeepSeek?
yes, yes, and it was not
Wow.
complete. So this list is still not complete because uh, Grok, which has the feeds from X and Twitter, so that has extra names which do not show up here. I did try to combine the list from Chad.com, like ChatGPT, from DeepSeek, but DeepSeek is not running; it's giving me server busy. Quen and Grok. Sorry, and yes, Grok. And I try to combine, and this is not complete because there are more that these systems don't know or don't capture yet. So this is what DeepSeek, Firework AI, Azure, GitHub models, Llama Gateway. I don't even know many of these names. Grok, of course, Open Router, Hyperbolic, AWS, Microcloud, GPT.
So,
uh,
so one
Oh,
thing I think would be tonight we'll probably have a lot of opinions, I'm going to guess, but I think one of the interesting things is what does this really imply? I mean, we've had, an explosion of activity and adoption and everything, but I kind of wonder um, if I can use the word hype, if it kind of feels a bit overhyped. There's fundamental changes, but boy, it's just getting popular attention everywhere.
I think
So
it's multiple. Go ahead, Sally. Go ahead.
I was going to say, I can offer kind of a business, like a long-term business perspective that I shared with my board today, because we had our board meeting today. And I don't feel it's overhyped. DeepSeek specifically is overhyped um, as a trend. As an individual moment in time, it probably is.
Yeah.
But if we look at the trend of AI over the last 20 years or so, 15 years really, right? Like since the original convolutional neural networks, Moez, Bakush, and kind of like the discovery of them, and then AlexNet, and then there was a massive explosion of funding. Probably like 40 or 50 companies got funded to create image APIs. There was a big scandal with Lenovo. They had a CNN that was running on the Lenovo. I don't know if you guys remember this, and it would scan the screens that you were looking at and send them back to Lenovo and then monetize them for ads. There was an Israeli company that did that, right? But there was all this explosion of monetization, and then massive commoditization in open source with CNNs. And now there aren't a ton of big API third-party companies that are getting funded at really high valuations. And as transformers came out, I would argue that this is the same thing. And DeepSeek is, whether it's AlexNet or it's the Microsoft one or Inception or ResNet or whatever it is one of the marked steps in the open source commoditization of the transformer space that makes it cheaper and accessible to research. It drives visibility and watershed moments in terms of capabilities that are available and accessible to everybody. And so I don't think that DeepSeek as a trend is in any way overblown. I do think that DeepSeek won't, if it ends up being AlexNet, nobody's going to give a shit about it in 3 years. But it was still the most important thing that happened in the development of CNNs. And so AlexNet was. And so I would argue that I think the attention is totally warranted, but maybe not as precisely as it's being directed. How about that?
Yeah, I concur with that. I will stop sharing so that whoever is sharing next can take that on. But just wanted to bring that. But to your point, Sally, I agree that this is the reason everyone is adopting it for two. Like there are two drivers for that. One is that it is open source, no license binding, so you can host it. The performance is almost at par as O1 in many cases. So essentially, everyone has capability to host an O1 like model and serve it, which is a big
everyone with eight H100s.
Still, still like imagine 101 versus 20 now.
Yeah.
So that's a big, huge leap.
Yeah, but I guess the point is that there was Llama, it was open source as well, and that had a big impact as well.
But there was always a gap between Llama and GPT-4o, a big gap.
Yeah.
Well, I think the other thing is there's so much money to be made, or the appearance of so much money to be made that, you say you need 8, fairly beefy, CPUs or GPUs systems to run it. That is not a barrier. I mean, I was talking to a friend. Well, Dev, what do you have? And you're sitting in your house next to you. I mean, you and I have had these conversations, and you've got a lot of pretty beefy hardware for a little home system, quote unquote home system. You could run a small enterprise, right? So
well, he's running a 32B.
Yeah. So Roger and I have been tinkering, and we got DeepSeek R1 running on my home system, a 32B.
Well, a distillation of it.
Distilled Quen.
Oh, yeah, okay.
Yeah.
I was going to say real R1, like you need some serious VRAM for that.
I think I can run R1 as well because I have a 64-thread CPU with 512 GB memory, which is sufficient to run. Not sufficient to run because you need 600 plus 700 GB memory. So if I had a terabyte of memory, I would have run that too on CPU.
Yeah. That I was going to say, I think probably the reason why it got adopted so quickly is O1 from OpenAI. It's restricted. Like not everybody can access it. You have to apply and get to level 5 or something on their API usage. So there were probably some services who wanted to use it and just simply couldn't. The other thing is that because the MOE architecture, and I believe there was some degree of innovation on the MOE. It's really, really easy to serve it, parallelize it. So it's not great for home use, at least actual raw R1. But it's fantastic if you're serving an API and your business is going to have enough H100s such that you can stack and then take advantage of the MOE efficiency when parallelizing. So that's kind of where I'm at with it as to why everybody jumped on it. That and the news went crazy for some.
So Dev, there was a question to you from Janeth on how you got that up and running.
Yeah.
So I'll defer that to Roger, but I know it's a straightforward answer, but still, Roger was the one who took my machine and did it. And then we just had a session together to get it going. I mean, it's very straightforward, but Roger, do you want to take it?
Yeah, I mean, it's just a Hugging Face. It's in the Transformers library, and it's just a matter of having a machine to run it on. So we can look at it, but it's super trivial.
Straight up Python.
Oh yeah.
Okay.
Because we're running the distilled version, so it's just the original one was just a Llama 7B, I think, and then it took a little bit more, but then the 32B Quen quantized down to 8-bit.
Okay, that was my next question.
Yeah.
QA. Okay.
Yeah, but it's easy stuff.
Yeah.
So,
cool.
It's kind of fun to play with.
Yeah, I mean, I tried it on Olama and VLLM, or we tried it. The same thing, the Quen 32B, but FP16.
Okay. Yeah, I didn't have enough for that.
So it's kind of interesting to see that thinking, where they have the think thing going on, and then the answer. So yeah, it was, and then of course you can get answers when you run it versus trying to hit it on the API.
Yeah, that was if we have. I don't know how this evening's going to play out, but if we have time, I thought maybe we could look at some of the thinking um, on the model because it is interesting and I kind of have some thoughts on what it implies. But I'm guessing kind of the flow tonight is some just open-ended chatter to start with. We did find one video that's what was it about 20 minutes, Jerry? I think.
Yeah,
Um,
somewhere in that ballpark.
for people that haven't seen the technical side of it. And then we can continue on. We can take a look at some of the output if we want, something like
Okay.
that.
Yeah.
Another idea is we could have a discussion, and then we could actually look through the paper, and then we can and then yes, yeah, stop and discuss certain points. And I think either would be fine, or probably a lot of it would be equivalent.
Yeah.
Yeah.
I think the other thing that came up in talking and with Jerry and Ted and whatnot is that there's a lot of innovation, or at least bringing together innovation in the DeepSeek papers prior to R1 that are really a lot of the magic happens there. So we're thinking maybe start with kind of R1. Let's talk about what is unique on the R1 version. But it seems like we could also do follow up next week on some of those earlier technologies. Ted did a really good presentation at the San Diego, I think, at the San Diego machine learning on the what's it called, MLA, which seems like a really key component. And I think DeepSeek, that was their innovation, right?
Yeah. So they created the latent attention as early as their V2 model, and then R1 was based on their V3 model, which also uses the latent attention.
Yeah.
Yeah. So anyhow, people are interested. I think that could be a good next week. We thought maybe just start with kind of R1 talk and opinions this week, and we can continue on next week.
Okay.
Yeah, and I think Yannick also has a video out on DeepSeek Math.
Yeah. Yeah. I haven't watched that one, but I did see it. Yeah.
Yeah.
I think that one goes into the reinforcement learning sort of like novel thing that they did.
Yeah, I think the DRPO versus the PPO.
Yeah.
Also a bunch of information about data collection, how they crawled the web, collected the math data, train it. So it was interesting if you're interested in the data collection part of it.
Well, I think that's kind of a key thing, right, for them, because they have all sorts of data. It's multilingual, obviously, because it's a Chinese-based company. They're putting up a lot of Chinese data in English and what have you not, and they have to deal with it. So it's kind of an interesting problem for them.
Yeah.
So if I could propose, maybe we want to go ahead and play the video for people who are less familiar. And I was thinking another thing is if people have specific questions that they were hoping to discuss, we could put those in the chat while the video is playing. And we will have time. Like I think Roger said, the video is only about 20 minutes. So we can get into deeper discussion. We can walk through sections of the paper if there are things that are particularly interesting for people. I think that would work for a plan.
That sounds good.
Sounds good. Who's playing the video? Roger, are you going to do it, or?
Yeah, I'm pulling it up right now. So
okay. Thank you, sir.
I didn't have it staged. So.
And so where is Roger today anyway? Are you back?
Yeah, I'm back home.
Oh, okay. Because it's like, just take a globe and throw a dart and you'll get near somewhere where Roger has been in the last 2 or 3 weeks.
Yeah, I had to leave those sunny beaches behind. Sunny beaches.
Yeah, rub it in, buddy.
Okay. Yeah, I will. If you're ready, then I'll go ahead and try sharing this. Share sound, optimize video. Let me know if you got that's up.
Says you've started. Oh, here we go. Yeah, you're up.
Okay. Sound on. Give me a thumbs up I can't see you. But give me a holler if it's you can hear it.
Good for me.
In recent years, the field of artificial intelligence has experienced rapid advancements, with large language models paving the way towards achieving artificial general intelligence. One recent remarkable model is OpenAI's R1, which introduced innovative inference time scaling techniques to enhance reasoning capabilities, achieving groundbreaking results on complex reasoning tasks. However, the R1 model is closed source. Today, we dive into a groundbreaking research paper by DeepSeek titled DeepSeek R1: Incentivizing Reasoning Capability in LLMs via Reinforcement Learning. This paper introduces a state-of-the-art, open-source reasoning model and provides a detailed recipe for training such models using large-scale reinforcement learning. Before we dive in, let's do a quick recap of the training process for large language models. Typically, large language models undergo three main stages of training. In the first stage, LLMs are pre-trained on a vast amount of text and code to learn general-purpose knowledge. This step helps the model become proficient at predicting the next token in a sequence. For instance, given an input like write a bedtime, the model would be able to complete it with a reasonable word, such as story. However, after the pre-training stage, the model still struggles to follow human instructions. To address this,
what was that?
Oh, the video was occluded. That's all.
Oh, sorry. It's okay now?
Yeah, it was fine. You just had something occluded it
yeah, a window popped up. Sorry.
Okay.
Okay, I'll back up just a couple. Okay, here we go.
Story. However, after the pre-training stage, the model still struggles to follow human instructions. To address this, we have the supervised fine-tuning stage, where the model is fine-tuned on an instruction dataset. Each sample from the dataset consists of an instruction-response pair, where the response is used as the label. After this step, the model becomes good at following instructions. In practice, large language models continue to be improved in a third stage using feedback. A powerful method for this is reinforcement learning from human feedback, or RLHF in short, where the model is trained on human feedback. Gathering large-scale, high-quality human feedback, especially for complex tasks, is challenging. Therefore, another common approach is reinforcement learning from AI feedback, or RLAIF in short, where an AI model provides the feedback. For reinforcement learning from AI feedback to work well, a highly capable model is needed to provide accurate feedback. The paper we are reviewing today eliminates or partially eliminates
Roger, you're muted.
Yeah, you.
Sorry about that. I just wanted to mention that we last couple weeks, 3 weeks, I guess it might have been, we were actually covering the RLHF algorithms and details. So I don't know if Jerry, if you got the videos up on that yet, but
yeah, they should. I believe everything's up right now.
I mean, there's a lot of good sources for a lot of good podcasts on the net about it. But if you're interested in this group,
so
through.
Yeah, we have about the last. How long have we been putting them up on YouTube? 3 years, 4 years, something like that. Anyway, the last bit of the on the West Coast ML under YouTube, you can find early meetings just like this, just like we recorded these. So.
No. All right. And a lot of the things that we were talking about in terms of RL and RLHF, they kind of tie into some of the things that they're doing with the post-training of this model as well.
It's the supervised fine-tuning stage, specifically to train DeepSeek R10, the first model out of 2 presented in the paper. We start with a pre-trained model called DeepSeek V3 Base, which has 671 billion parameters. The supervised fine-tuning stage is completely omitted. Additionally, to be able to run reinforcement learning at large scale, we don't use the standard reinforcement learning with human feedback or AI feedback, but rather a rule-based reinforcement learning. Let's expand on how the rule-based reinforcement learning works. The method is called Group Relative Policy Optimization, or GRPO in short. It was developed in-house at DeepSeek. Given a model we want to train and an input problem, we feed the input into the model and sample a group of outputs. Each output consists of a reasoning process and an answer. The GRPO method then observes these sampled outputs and trains the model to yield the preferred options. It is doing so by calculating a reward for each output using rules. One set of rules is used to calculate an accuracy reward. For example, in the case of math problems with deterministic results, we can reliably check whether the final answer provided by the model is correct. For code problems that come with predefined test cases, a compiler is used to generate feedback based on the test cases.
Roger, you're muted.
Sorry again. This is one place I wanted to stop and talk for a moment because related to the last few weeks of what we've been studying, I think this is misstating in a way. The rule-based reinforcement learning is separate from GRPO. I haven't heard of using rule-based reinforcement learning in all of our RL discussions. Generally, so again, looking back to last week, we studied something where the RL used something called PPO. What is it?
Proximal policy.
Proximal policy optimization, yeah. And in that case, it was based on what was called an actor-critic, where you have one neural net is looking at the behavior, looking at the trajectory, and looking at the rewards. And it is informing the policy neural net. And so you're training it, basically using it for the gradients to decide what the optimal policy is. But the critic is determining the value of each state, and then that value is used to determine the advantage in a A2C model, used to determine the advantage at a given state of choosing one action over another. And so that's very close to what's going on here. But instead of using a neural net, they're using essentially, as I see it, and Ted, maybe you have a different opinion here. You've read about this quite a bit, but it looks to me like they're just doing a Monte Carlo, essentially, a Monte Carlo estimation of the advantage of a particular action over the other action. So again, two different things. Rule-based is one thing. They have a rule that says if you do math, I know what the answer is, and I can tell if you got the right answer or not. And then the second is GRPO is changing the actor-critic and getting rid of the critic as a separate neural net, and just using a Monte Carlo type approach. Does that make sense, Ted? Would you disagree with anything I've said there?
I haven't had a chance to read too many of the details about GRPO yet. I do know the big deal is that the critic model takes up a lot of GPU memory.
Right.
So if you can estimate values without having to have a full-sized model, then for somebody who's particularly has GPU scarcity, that's a big deal.
Yep. Okay. Any other questions, comments? I'll hit play again. Okay.
Type of rules helps to create format rewards. In the following table from the paper, we can see how the model is instructed to provide an answer, putting its thinking process within think tags and the answer within answer tags.
Thanks, Theros. I'll make sure to give those to Peter. He was supposed to teach me everything, you know.
Mechanism, no neural model is used.
Okay, you want to take my...
Making the training process both simpler and cheaper, supporting running this process in large scale. Additionally, the researchers found that such models may suffer from reward hacking, where the model discovers a loophole or unintended way to maximize the reward, which does not align with the desired goal. In a moment, we'll proceed with performance insights and the second DeepSeek R1 model. But before we continue, if you're finding this content valuable, please don't forget to subscribe and hit the like button to support the channel. We also send 1-minute read summaries by May about the papers we review here. You can find the link to join in the description of this video. Let's now discuss a few performance insights of the DeepSeek R10 model. In the following table from the paper, we can see a comparison with the O1 model on reasoning-related benchmarks. Impressively, DeepSeek R10 is comparable to O1 and even surpasses it in some cases. Another interesting figure from the paper shows the improvement progress during training as measured on the AIME dataset. Notably, the average +1 score on AME shows a significant increase, jumping from an initial 15.6% to an impressive 71.0%, reaching performance levels comparable to OpenAI's R1. Another key insight is the self-evolution process of the model, illustrated with the following figure. The x-axis shows the number of training steps, and the y-axis indicates that as we progress in training, the model's responses lengths increase. Using reinforcement learning, the model naturally learns to allocate more thinking time when solving reasoning tasks. Amazingly, this happens naturally without any external adjustments. If that
So this is another place I'd want to pause. That I thought this. Let me see if I can back up. This is kind of interesting because, as I understand this graph, they're basically saying the more we train it, we're getting longer and longer responses, and they're saying that as though that's a good thing. And when Dave and I were looking at the thinking process, it seems like the thinking process is very verbose, very wordy, goes around and around in circles, and I kind of look at it and wonder if there's a mistake here, because longer is not necessarily better. The accuracy is what's important, and yet they're somehow viewing it as longer as better.
One thing I'd note is that if you look at the previous graph, that kind of seems to kind of start plateauing a bit towards the end, where this one is still, I mean, there's probably a couple of things we can discuss, but it seems that this one, it seems to be like plateauing a bit, whereas that one is still kind of going up in a
I think you're measuring it's measuring two different things, isn't it?
Yeah,
on
yeah.
the y-axis.
I think this is the accuracy, and the other one's like the graph of the length. It seems like it's getting longer and longer. Performance isn't necessarily which kind of makes
I see what you're saying.
It's like, and I think we might have mentioned this kind of thing before, Navia, but it seems you think it might have chopped it. You'd go to maybe like an even 10,000, but they kind of had it stop there, which I mean, which kind of makes you wonder a bit. But even then, it's like, well, I mean, if you make it longer and longer, there's other kind of disadvantages. Like you might
inference time
increase the chance, that it says something to throw it itself off or things like that.
Yeah, exactly. Yeah, again, we can look at them later on, but you get to where it has a lot of. So it's good, I think, when it learned to say, "Oh, wait a minute, let me reflect, let me go back and kind of question some of my assumptions and see if I need to rethink that." So that seems like a good behavior to learn, and pretty cool that came out of just RL. But it gets in a mode where it's really uncertain, and it just keeps it. Sometimes it can get stuck in these loops and just can't reach a conclusion. And at inference time, that all costs money. So it seems like there should be some sort of cost associated with a longer response, and the main reward being the accuracy. Alan, were you making the point that these lines still seem to be going up? The accuracy seems to be going up. Why did we stop here?
No, as in this started plateauing a bit if you look between 600 and 800, but the other one is still kind of. And it's still flattened out.
I guess it depends where you draw the line there. It could be that's flattened out. I guess
it's shallowing out. That's for sure.
For sure, yeah.
Whether it
and
plateaus.
I can see where. So if I have a lot of self discussion about the problem, that the longer I talk, the bigger the chance that I'm going to drop some sort of hint in there that's good and that will guide me towards a solution. So I can see where a longer self-reflection will increase the accuracy a little bit. But it's like you said, it's kind of this plateau. It's getting to a point where my inference cost is getting higher and I'm not really getting a lot more accurate. And should I really be rambling on like that? Ted, I see a hand up.
Yeah, so I wanted to share that I think the conventional wisdom is that chain of thought reasoning is good. So I don't think anybody claims to know enough to say whether or not in the long view, 2 years, 4 years from now, okay, is chain of thought going to be like the answer, the end all and be all kind of a thing, right? But in the short term, I think everybody's saying that with the LLMs that we have today, when they take more tokens and they do intermediate steps and they explain their thought process, it's very clear that they get higher accuracy on reasoning heavy tasks like math problems and on coding. Okay. So I would say that no, you don't want longer for longer's sake. But what's interesting about that next graph, you backed up to go back to this one, right? But what's interesting about the next graph is that they never told the zero model to do chain of thought. They like kind of hinted at it, but they didn't very explicitly tell it to do it. And they never told it to do longer chains of thought.
Yeah.
They simply rewarded it based on the accuracy of its answers. And so this seems to be a validation of the conventional wisdom that with the way next token prediction LLMs work today, the longer the chain of thought on average, the better the answer. But I would say absolutely, if you have a really simple problem, like you just want to reword a one paragraph email, you probably don't want to use O1 or the new DeepSeek R1. You just use regular vanilla GPT-4, ChatGPT, whatever, and that's totally good enough. And then this particular version, you wouldn't even want to use it for creative writing, for writing a short story or a poem or something like that. I've seen examples where people are like, yeah, it spat out like 3,000 tokens before it even like came up with one sentence.
I think the point that Roger made about sort of longer isn't necessarily better, costing more, I think is right, and I think there could be a number of other kind of potential shortcomings with this RL process, and I think one of the key points is that R1 itself isn't just this. This is R10, and I think they do sort of fine tune, do some fine tuning with manual. With its
he'll cover that
human curated data, and so that kind of in effect can kind of alleviate things like overly long kind of processes.
If I may, Alan, I think you're really going against conventional wisdom. If you're someone who's trying to design a new antibiotic, you're trying to prove new math theorems. Like paying a few thousand tokens is a relatively small price compared to just simply getting an incorrect answer.
Okay, yeah.
Like these are $1 million problems that if you can design the next antibiotic just by throwing, let's say, 10,000, 100,000 tokens at the thinking, go for it, man. Does that make sense?
Okay.
Yeah, Ted,
I think for brainstorming kind of applications, I certainly see that.
Yeah, but again, don't use this just to ask it for the definition of a word that you saw. Like overkill.
I think there's a couple things there, Ted. One is your comment about sometimes you don't want to always use the R1. It's like if it's a problem you need to really think about, then use R1. If it's something that's quicker, you actually get in some ways better answers out of just the V3 model. So when it gets to be general purpose, it seems like somehow the model should know, do I need to think about this? Do I need that mode, an R1 mode? Or can I do a quick, what is it, the slow think, fast think, or something like that? It's like the models, you would want it to figure that out. And the other thing is, I wouldn't argue against spending more time at inference to get better answers or solve more difficult problems. But when we look through it, I think to me at least, it looked like there's work to be done to make this self-reflection more efficient, because what it's doing right now just doesn't, to me, look efficient.
So for the sake of being specific, what are some problems that should be fed into R1?
Yeah, so I would say R1 is not yet tuned for good agentic use. Okay, so if
Okay.
right now you just had a bunch of them talking to each other, it might actually flub. Okay, but I would say that if you're doing like agentic tool use um, to try to design drugs, then any any slight boost you get in reasoning capability could be the difference between, you try six things and you get a successful drug versus you try 100 things and get a successful drug. And that's worth like $1 billion, right?
The other thing that I would posit there is the things like extraction, summarization, like find this part of the large corpus of data I'm going to feed you because I don't want to like read through the whole thing, classification, stuff like that. I think the general paradigm that seems to work, or like one of the ways that I tend to use models is I have an architect model that plans out the code changes, and then I have an engineer model that goes and implements the code changes. So for the how I used to run this was O1 would be the architect, and then Sonnet would be the implementer. I think like that kind of separation is kind of how I would do it. Like the longer, like the things that I'm not in a hurry to get an answer for, but I really want the correct answer is where I would use R1, and then the like, okay, we've got it figured out. Now I just need like something competent to make it happen is where I would use like normal DeepSeek basically.
Got it. It also makes me think of like if I was, interviewing, say, 1,000 people for a product that I'm developing, and I just poured 1,000 interviews, 1,000 1-hour interviews worth of data into R1 and said, list out my design inputs, list out exactly what I need my engineers to do to improve this product or for the next version. Would you agree?
In that specific case, I'm not sure because there that I feel like that kind of if it was like provide me for like in the context of all of these interviews, like provide me some sort of like general opinion that the majority of users expressed or something like that, where you're not having it tackle a complex reasoning problem so much as you are doing like a data extraction problem is where I would go like not R1. But for a case like that, if I both need to go through a large corpus of data and do complex reasoning about that data is when I would still pull in R1, I think.
Got it. Okay. Thank you, Ted. Thank you, Warren.
Gina.
Yeah, so couple of things I was thinking about, back to the average token length. So as you increase the accuracy, as you're sort of saturating, it gets harder and harder to push that curve up.
Mm-hmm.
So I imagine that, for those very difficult problems, perhaps you need to think deeper, therefore you need to do more tokens, something like that, right? But the surprising thing is that what they're plotting is the average. And the average seems to go up so much, it's almost like a 10x. And so it's like for, let's say you have 70% in the end, right? So for the 50% that you gained earlier, you didn't really need so much thinking, but you seem to have on average increased your thinking even for those 50% perhaps.
Yeah.
And so is there like a discrimination in the model to say, what, this is a really simple question. I don't need to think that hard versus this is more complex. Just looking at the average going up so much.
Yeah, I mean, in real world problems, what you have is like context is most of the big reasoning models are good at context, but exact recall is the harder thing. So you had in your YouTube thing, the Google Titan, that architecture is supposed to actually include the exact details exactly. And I just ran 50,000 word data set, and it was like O1 had a hard time with exact, the correct author names, correct quotations. So it approximates some things. So like LLMs are trained on, vast amounts of data, and its number one goal is to get the context correct. And then all the other like fine details, that's what the reasoning models are having a harder time with now, is if you ask it to return exact quotations of specific, like the lady said, like if you have 1,000 examples or 1,000 shots of something, it's going to be harder for it to, do those things that are only listed in your input like once or twice, as opposed to it really likes to see patterns. So things that show up multiple times, if you have like 50,000 words or above and these context lengths. I think the DeepSeek is a 160K. That's what my question was in the chat is, has anybody actually done this with a huge real world problem? Because I think that we're leaving the stage of benchmarks and going into reproducibility at this stage.
I certainly haven't played with any of the long one. And of course,
is your question like, has anybody tried a 160K context size? I'm sure.
Yeah.
I'm not sure about the question.
Yeah, big. So, number of tokens plus complexity, so volume of data complexity with DeepSeek. I ran it with my 50K data set and it was able to do context, but this DeepSeek model couldn't actually, this is like 3 prompts. It couldn't actually give me the exact quotations that I wanted. It could do authors' names. So that's the issue that I see with these models. It's not these like little benchmarks where ChatGPT has their benchmarks and DeepSeek beat them barely by, those same benchmarks. It's actually the big real world problems that we need to solve in the world today, as opposed to like these smaller kind of things.
Yeah. So I mean, the few things that we have tried in terms of longer context windows, it was able to handle it okay. But I guess you're talking about like it paying specific attention to very specific.
Yeah, did you go like line by line? So like I can create through the Google model, I can create a 5,000 word output and I go line by line and all of the quotes were correct and the author's names were correct. It's just, when I use DeepSeek, like I said, they weren't even providing precise details that will be required out of more complex problems.
Yeah, I gotcha. So I guess our problem was different. Yours is more like a needle in a haystack, finding that kind of thing. But ours was more like give it a lot of context and then get out a lot of output as well. And it seemed to do okay in that.
Yeah, I mean, that's going to be the thing going forward is how well you can actually, like, I have to human verify all these things it's called grounding the input to, or grounding the output to the input. And I have to go line by line and check all the quotes and check author names and those types of things. So that's just how it is, because we don't have anything better than the best models to check it.
Right. I mean, the task we are doing is different. It's kind of like how they have the math and the code set up. So you're able to easily verify what the model produces. In the math case, you probably already know how to solve that, or in the code case, you just see if you can run the code and get the right answer.
Yeah. So the thing that I'm talking about with benchmarks, you need to have a qualified, like multiple choice, like A, B, C, D. And that's how ChatGPT O1 versus DeepSeek R1 is it needs to be verifiable, like the percent of those actual answers were correct. And that's what it's harder with the reasoning models and context is because you have to actually go through a human verification at this stage to verify that all that information is right.
Yeah, for that task, right.
I think what you're saying kind of goes to a bigger question of how to make algorithms for like real world and not only just benchmarks. I think that is just overall, I think that's a big topic in and of itself. Because like if we're working with benchmarks, or like you can have training data with labeled ground truths, but with with real world products that need to interact with different users of different levels of skill or different familiarities with technology. That's just a kind of a much harder kind of problem that doesn't necessarily lend itself to kind of benchmarks or other kind of sort of kind of training and inference techniques.
Yeah, I mean, essentially, I think that's what all the news was, is it beat OpenAI O1 and its own benchmarks that it used. And, that was the conclusion. And then it did training, not inferencing, I don't believe, training, at 5 million instead of like 100 million. So, yeah, I mean, it's going to have to change because the quality is caught up with the speed. There's always been speed advantage since a while with LLMs, but now that the outputs are highly accurate, able to handle voluminous and complex data, many orders faster, and better quality, then I put myself up against the AI on occasion. That there has to be something beyond all these benchmarks, going into real world problems. And that's what it takes, is just like somebody big in science to say, like, we solved this huge problem and we can verify it, all these different ways using the LLM. So we start to leave the benchmarks, and it's kind of risky because the DeepSeek they're aiming for those benchmarks, right? That OpenAI said that they just got with O1. And then we're probably going to be hearing of O3, in February, and then I'll have new benchmarks, So yeah, that's where I see the industry leaving all these kind of like silly, like benchmark kind of queries and going into like, oh, we just solved this massive problem and we can back it up.
Hey guys, let me, I'm gonna, if you don't mind, pull us back to the R1 and continue with the video, if that's okay.
Thanks, Roger.
That as we progress in training, the model's responses lengths increase. Using reinforcement learning, the model naturally learns to allocate more thinking time when solving reasoning tasks. Amazingly, this happens naturally without any external adjustments. If that's not enough, there's another phenomenon which the researchers refer to as the aha moment of the DeepSeek R1. We can see this in the following example from the paper. Given a math question, the model starts its reasoning process. However, at a certain point, the model begins to reevaluate its solution. The model learns to reevaluate its initial approach and correct itself if needed. This is crazy, and again, it happens naturally during the reinforcement learning training.
Just to be clear in here, this highlighted red text is actually part of the text that the model generated. So this wasn't added to the output. This is the output of the model, and the model itself said, wait, that's an aha moment, which must have been a little.
So wait, it understands the concept of an aha moment.
I mean, when you saw that in the output, you had to have said, "I'm going to put this in the paper," because that was weird to see that. But yeah, I wasn't quite sure when I first saw this, if that's something they'd added or something, but no, that is what the model uttered.
Oh, so, wow. I always assumed it was, when they put this figure in the table in the document that they said, here, just to show where it was.
Now the model thought it was an aha moment before they did.
Even I don't have that level of emotional awareness,
Yeah, the LLMs are actually not autistic, unlike the rest of us. So it's a.
Hey, speak for yourself, Sully.
I am speaking for myself.
For what it's worth, if you look at some of the other stuff that's between the think tags, it does have a very informal, chatty, anthropomorphized voice.
Mm. So. Yeah. Yep.
Yes.
We'll take a look at one of the ones that Dave and I did, and you'll see that. And I agree, Ted. It's very informal and wordy. Okay, let me continue on now.
Let's now move on to discuss the training process of the second model called DeepSeek R1. But first, why do we need a second model given the remarkable capabilities we've just seen? There are two main reasons. First, DeepSeek R1's outputs suffer from poor readability. Second, it often mixes languages within a single response. Both issues make DeepSeek R1 less user-friendly. An ablation study actually shows that guiding the model to be consistent with one language slightly damages its performance. It is quite fascinating that the model learns to express itself better by using more than one language, unlike humans, which usually stick to a single language. To address these issues, DeepSeek R1 is trained in 4 phases. We start with the pre-trained model DeepSeek V3 base. In the first phase, which is referred to as cold start, the model is trained using supervised fine-tuning on a small dataset of results collected from DeepSeek R1, which were validated as high quality and readable. This dataset contains thousands of samples, making it relatively small. Incorporating a supervised fine-tuning phase on this small, high-quality dataset helps DeepSeek R1 to mitigate the readability issues observed in the initial model. The second phase is reasoning reinforcement learning. This phase applies the same large-scale reinforcement learning we reviewed for the previous model to enhance the model's reasoning capabilities, specifically in tasks such as coding, math, science, and logic reasoning, where clear solutions can be used to define rewarding rules for the reinforcement learning process. The third phase is rejection sampling and supervised fine-tuning. In this phase, the model checkpoint from phase 2 is used to generate many samples. With rejection sampling, we only retain correct and readable samples. Additionally, a generative reward model, DeepSeek V3, is used to decide which samples should be kept. Some of DeepSeek V3's training data is also included in this phase. The model is then trained on this dataset using supervised fine-tuning. This dataset includes more than reasoning-oriented questions, enhancing the model's capabilities across more domains. The fourth and final phase is another reinforcement learning phase, which includes diverse tasks. Rule-based rewards are utilized for tasks that allow that, such as math. For other tasks, a large language model provides the feedback to align the model with human preferences. It's also worth mentioning that various smaller open-source models were distilled using the dataset constructed in the third phase, offering smaller alternatives with high reasoning capabilities. We conclude this video with the following figure from the paper, showing the remarkable results of the freely available DeepSeek R1 compared to OpenAI's O1. We can also see impressive results for the 32 billion parameters distilled model. Thank you for watching and stay tuned for more reviews of AI papers.
I want to back up here. There was a lot packed into this one slide. So this idea that they were doing, let's see, where did they do? Oh, they didn't talk about they mentioned that, I guess it's not on the slide, the distillation into smaller models. Ted had made an interesting comment earlier in the discussion that they call it distillation into those models, but in the paper they talk about it just as being supervised fine-tuning, which may or may not be kind of the classic definition of distillation, as I know it is. You have a teacher, you output the logic, so the teacher and the student learns the logics instead of just whatever the output would be, the tokens in this case. So it wasn't clear in the paper, it wasn't clear whether their distillation process, they did say it as, they described it as offline, if I understood. In other words, they generated the data set and then they trained on it afterwards, but it wasn't clear whether they were doing classic distillation with logics or if they were doing just kind of a synthesized data set training. So that was one thing. What else was I going to say in here? This one, then they went backwards where they're now doing the supervised fine tuning before it. So in the 0, it's actually interesting because alpha 0, didn't that go the other way around? They started with some like human features, and then alpha 0 got to where it had no human features. In this case, they started with the 0 and then decided to throw some of this what I thought was human generated SFT data sets, but it sounds like it's human curated, but R10 generated examples. So pick the more readable ones. The human selects which is the more readable ones, and that becomes the data set for the SFT. Was there a hand up? Did I hear a hand up?
It's got a hand up.
Yeah, thanks, Roger. So I just wanted to comment that I think that the 0 model switching languages seems to me to be a pretty reasonable behavior. We had a little bit of a discussion in the chat. People pointed out different ways in which humans do that. But the other thing is, if you look at reinforcement learning, it's just maximizing your reward, right? And the reward is the correct answer to a math problem or something
Right.
like that. So it really doesn't matter whether your intermediate thinking was in English or Chinese, or if you actually just switched back and forth. Now, AlphaZero or its precursors didn't use language, so it's not really a proper analogy. But the reality is, if it played chess and it beat the world champion, you don't really care if it switched between English and Chinese as it was thinking about what move to make next. You just care that it got
well,
the
and
right move.
didn't AlphaZero, they said it thought differently about the game, right? It played non-human moves because it
well
never
it did that, but it didn't use language. So
yeah.
the analogy breaks down very quickly. Okay, but I'm just saying that like so I feel like it was like, oh yeah, you just simply didn't particularly direct it. It needed to do that, and a little bit of fine tuning goes a long way in terms of showing it what you actually think is proper conversation.
So Ted, I had a similar question as I was reading that part because again, getting back to the casual, very verbose thinking that I've seen in the R1 zero, I would like to have seen what the thinking actually looked like. Was it does the thinking need to be human readable? No. The only thing that needs to be human readable is the final result. And I can see incentivizing it so that the final result doesn't change languages, like it should be one or the other. But I, like you, if it's, did I see somebody said, actually, that's the way people work, that when you're thinking about stuff, bilingual people are going back and forth between the languages. And it doesn't seem like there's anything wrong with that if the model would think bilingual, as long as it output in a single language.
I don't know. I wasn't there, but I suspect the researchers may have other motivation, and I haven't seen anybody say that they were surprised, that they thought that they should have dug their heels in and tried to figure out a way to get it to work with just RL. Pretty much everybody, everything I've seen, people were like, okay, yeah, that makes sense. They did some SFT to give it a good starting direction. Because it's much, since we know what a natural conversation between a user and an assistant sounds like, it's a lot easier just to say a small number, whatever, 500, few thousand. We have plenty of those. We'll just give it some examples to really show it, rather than having to figure out a reward scheme to like exactly reward the right type of assistant interaction. Does that make sense?
Yeah, I guess there's two different things. One is how do you incentivize it, or how do you guide it towards one behavior, whether that's RL or just examples. But the other is when they did their examples, you could have let it be bilingual thinking, single language results, and guided it towards kind of that model. Especially if the thinking bilingual is a higher, more accurate. Why?
Yeah, I don't know if anybody else has anything to contribute. I do think the path of least resistance is I've got tons of examples lying around. Why don't I just show it?
Could be, yeah.
Yeah, I think the reason might have also been if some of the researchers were working on this and testing it out and seeing, if the answer isn't right, could I have looked at, the reasoning trace to understand, have some clues of where it might have gone wrong, and if they don't, he or she doesn't speak Chinese or doesn't speak English, then that kind of might be a problem. So just in developing it, that could have been a reason as well.
Yeah.
Something I do want to point out here is that and like it seems to be coming up a lot lately, where there are several papers that seem to indicate that the reasoning steps don't need to be like logically consistent in order to see a performance increase. So rather than actually correctly thinking through the problem, it essentially only matters that it's spending more inference during test time in order to arrive at better answers on average.
Yeah, that makes sense, Warren. Yeah, so it's not really what does it look like? It's just is it helping to arrive at the better answer?
Basically, yeah.
Yeah.
So that kind of ties back to that graph that we were looking at earlier, right? The
Yeah.
longer. So the aha moment that it talks about, I was trying to read through that. Like, I couldn't see what it did later that was really aha.
Oh, I
I
mean,
don't know if anybody
just for an
actually
example,
tried to read the proof,
I
the
didn't try
math
to read the
proof.
proof. I mean, I got to let's reevaluate this step by step.
Yeah, I mean, it
I wasn't.
says it's aha, but was it really an aha moment?
It looks like that slide is incomplete to me. Like it looks like
Yeah.
cut it off.
Yeah.
Yeah, it is. Yeah, it is. Yeah.
What exactly is being shown in the slide? This is it coming out in Markdown, or how do you get it within the mathematical symbols?
Yeah, it outputs some sort of formatting. I've seen that in some of the
Probably
examples.
LaTeX or something, I
Yeah,
would guess. Yeah.
yeah.
Okay, that's
I wonder.
useful.
I
Like
wonder.
like any good academic, right? It writes directly into LaTeX.
Yeah.
Yeah,
Really,
why wouldn't?
that would actually be extremely interesting. Because largely because they have like the majority of models when they are using latex or like actual proofs, like they need to use an external tool, which is why they're not good for doing things like solving complex math proofs. So if this is actually outputting actual latex or code that would generate latex, that's actually really, really interesting, especially if it just sort of like started doing that of its own accord. So I would love to figure that out for real.
I have an example. We can jump over to the small version that we were running on Dave's machine, and we can see some of the formatting. But this was one of the ones I wanted to show. So I was just running some GSMK, which is a math, I think it's grade school math or something like that benchmark, and was running through. And I noticed that it was pretty good accuracy with, I think it was the 32B that I was using, the 8-bit 32B. Pretty good accuracy, but sometimes it wouldn't answer you wouldn't get an answer out of I'd limit it to like 2,000 characters and I wouldn't get an answer. And so I thought, well, maybe that's something about the smaller distilled model, and went back and posted this question. So this is the prompt out of the GSM-AK. So pretty simple. Two trains leave San Rafael at the same time. They begin traveling westward, both traveling for 80 miles. The next day, they travel northwards, covering 150 miles. What's the distance covered by each train in the 2 days? So a little bit of red herring. It's, why is it two trains? That doesn't change the answer, it's kind of distractors. And then you got to kind of, you could maybe, the most obvious, at least to me, was, okay, they mean, how much down the track. So it was 80 one day and 50 the other, so 230. But you could maybe have this ambiguity about, well, do they mean what's the distance from the beginning point to the end point? Maybe. So when I did this and I put it into here, this is the text that it starts generating. So this is the kind of casual type of language that they use, right? So, okay, let's see. And it starts describing the problem, and so I need to find the total distance each train traveled, right? Question mark. I'm not sure how these tokens improve guide the model to the correct answer. So that's why I'm kind of saying this informal, casual, conversational mode that it has for thinking seems to be me not be as efficient as it might be. But the thing is that it went on, okay, so they're both doing the same thing. So maybe the answer is just adding two distances together. It actually got an answer fairly earned, but maybe they're trying to trick me. Like maybe they want straight line distance, blah, 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 blah. Wait, I might be misinterpreting. Maybe phrased in a way that might confuse someone in calculating displacement instead of total distance. Blah, 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 blah.
Wait, that could be ambiguous. Let's check the word. Like it's so.
Yeah. Yeah, exactly.
This is what happens if you get locked into solitary confinement for more than 6 days. Oh my God.
The problem is in Chinese originally. Wait, no, the user hadn't specified that. So I mean, it's kind of interesting the things that it's considering, but this was a pretty simple problem. This was one of the early GSM 8K questions, and it goes on and on.
And it analyzes different forms of English. Oh my God, are you kidding me?
Yeah, and then okay, so finally it did get down to the right answer, and so that was interesting. But it just was interesting how long it took to get there.
Well, and I think that's maybe the kind of the point that they're making about, or that people are, or that the claim is that the reasoning models aren't actually reasoning, which I would essentially kind of agree with here, sort of because of the previous point where it's like that thinking process, it could just be spitting out complete nonsense, but it'll still get a performance increase as long as it's spitting out something prior to giving a final answer.
Right.
Like when you use the website, you're looking at the full model, and anyone installing this on their local machine is not going to be using the full model, right?
Right. So this model here, this output.
I just want to add one more thing, that before we jump to the local machine, which is a smaller model, a DeepSeek to OpenAI O1 Pro comparison. So we gave the same prompt to O1 Pro, and it took like 5.5 minutes.
And how long did this one take, Dev?
This one was 144 seconds, the one that he previously showed, which is like 2.5 minutes.
Two and change, right? So yeah.
Really? Wow.
Yeah.
Well, off the top of my head, it feels like if you're rewarding it for getting the right answer and getting the right format, but there's no penalty for how long you take, then that's gonna kind of there's not really much of a so-called I guess you could say like evolutionary pressure to kind of give shorter answers that answer the question.
Yep.
And it's like one of those features like kind of male. I think of it as like a bit like sort of male pattern baldness, that it's annoying that we have it, but it doesn't stop the next generation, so it just keeps on happening. But yeah, I think, and it's also because I think it's just really hard to kind of use it. That's kind of one of the downsides of like a rules-based system to kind of assess that, which is why. I don't know, which is why maybe RL, like this kind of RL and the R10 hadn't have been done that much before. Why, maybe some researchers were a bit reluctant to try it. And as you say, we may be seeing some of the symptoms here.
Hey, Alan, before I put you from the meetup, just really quick, are you saying that male pattern baldness is a negative reward in reinforcement learning? Just everybody can say goodbye to Alan.
No, I mean,
to be fair, I mean, it's like I've had to cop it sweet as well. I mean, this photo is probably it's
the evolutionary
a while
pressure,
back.
guys.
R0
Like, you guys
spinning
are
in
getting the
circles,
inverse of it.
contemplating all the possible answers here, my friend.
If you had a genetic algorithm,
exactly,
baldness would be the negative, right?
Well, someone said something about overkill, and that almost makes me think, could it be that because we're giving it an easy problem that it's almost confused, it's overthinking it? Could it be that if we gave it a complex problem, it would take the same amount of time or even less?
Well, here,
I think ambiguity comes into it. I kind of came up with problems where it was an ambiguous question. It was like, here's a situation with two men do this, and then at the end I asked, how much did he spend, without specifying which of the two men I was talking about, and it detected that was ambiguous and went on and on and on and on, trying to figure it out, rather than saying, this is ambiguous, you need to clarify. So it's another part that it seems like it hasn't been trained for, is if you get in that mode, you need more information, prompt for more information.
So it needs the user to be really good at giving a specific prompt.
Well, I would argue that the models need to get good about understanding when it's insufficient information, and they need more information from the user.
Okay.
Well, it did get the answer earlier, but then I think because, people are telling these LLMs, hey, you need to be more thorough with your answer, it probably felt like it needed to go through and check itself.
Yep.
Roger,
Grant,
do you
you've
know?
had your hand up for a while. Can unmute and come in.
Yeah, I'm a little rusty, and also I realize the human analogy kind of breaks down pretty quick, but I feel like we're talking a lot about how chatty they are, but I think we would be shocked at how much goes on in our head, right? Like, I mean, when we read a problem, I mean, there's a zillion things going on, right? So like, it's probably way more than all of this.
That could
So
be.
I guess I'm saying this doesn't surprise me at all.
I wonder if that, we have various neurons firing, right? And perhaps in opposition, to each other, and then one overrides the other, and that is just not shown. And this is showing it.
Nitin,
Yeah, in my
Nitin
experience,
had a
like
question. Let's see, Nitin had his
Yeah, so I just wanted to make a comment about ambiguity. I don't know if you looked at the humanities final exam data set that had all the questions, the super hard questions. I think part of what makes it so hard is that they up the ambiguity level very, very high.
Oh, really?
Yeah, like you can, I mean, read the questions where you have domain expertise, whether it's physics or math or whatever. And you'll see that it really, like you trying to solve the problem yourself, you're dealing with like, my first impulse would be like, go and clarify this question, please. All right, so.
You mean going back to,
yeah.
In other words, you haven't given me enough information. I need more information, or I'm going to make this assumption.
Yeah.
Type of thing. Yeah. It seems like that's lacking in the training right now.
Yeah, sometimes it'll come back and ask for more information, but the biggest thing is usually the user prompt itself. And your English has to get to such a high level because these models are getting so proficient, especially with context, that a lot of times you have to reread it, triple read it, double make sure everything's right. And there are some limitations to say if I wanted to say a very detailed report and then on one of these it timed out on me, or if I say 4-page report, it tends to be like on one of these models, like 4,000 word output. So you do have to work with the model depending on the model as far as, what the answer is going to actually look at. But it's a humbling experience because a lot of times it's limited by the user's your own use of English and how specific you are to rule out things that could be deemed something else.
Mm-hmm. Okay, well, let's see. So I was just going to show real quick. So these are the types of questions or problems that you get in the GSM-8. Okay, and this is the generated text to answer some of the simple ones. It almost always, who was making the comment earlier, Janeth, maybe, that it always seems to use a lot of words, even for, the pretty simple ones. I'd actually be really interested in seeing what the non-R1, so the V3 model, if we fed it the GSM-8K, what responses it would get and how it affects the accuracy, because that would be kind of interesting to see. Can I think fast for some of them instead of doing this long reasoning? So.
Does anybody have any thought on why it does certain things? It's saying like, oh, okay, so let me figure this out. Those feel like they don't add value to anything, right?
That's my gut feel. Yeah.
It's
too colloquial or
is it just trying to be, is that programmed in that it should try to be very super verbose about, and conversational with the end user?
It would be interesting to see what the SFT data was that they gave it before the reinforcement.
Right.
Like, does this style come from that original data set?
Jerry, I'll bet you it knows, Like if I was this LLM and I knew some stuff, like I would read what follows after a wait. This is really important. I would read that subsection much differently from I would read, oh, this is just a guess.
The other thing is like if what it's doing is predicting tokens in order to receive reward, what it's doing there when it's saying like let me, stuff like let me make sure I'm not missing anything, it's not actually saying that like a human would. What it's doing is like re-rolling the latent space such that the confidence metrics are sufficiently high where the end result of the output should result in it getting the reward signal, right? So like I think especially with reasoning models, I think it's important to like not to try to anthropomorphize as little as possible, because that the reasoning that they're doing is like it's not equivalent to human reasoning, at least as far as my understanding.
Mm-hmm. But it's trying to appear human in its output so that you can communicate with it better, perhaps?
Well, the thing is that it is producing output that is intelligible to humans only because the training data is on human language, right? So like the thing that it's doing doesn't have anything to do with like how humans talk to each other, other than the fact that that's the only thing it has, essentially.
So that's why it'd be interesting, Warren, to see what this looked like in the R1 0. Because you can imagine that in the beginning, it was only incentivized to generate tokens that helped it arrive at the correct answer.
Yeah, exactly.
And they went back and say, wait, no, we're going to make you, we want it to look more intelligible.
Well, I actually don't recall from the paper exactly whether they primarily did that like post training in order to make the reasoning more intelligible, or if they just trained to make the output, the end result more intelligible, and that ended up with getting rid of the language mixing.
I think that's ambiguous in the paper.
Mm-hmm.
It doesn't specify which of those two.
And I think where a lot of this is coming from is chain of thought, because some of these models will give you the full chain of thought, and I've seen up to 500 words. Now, something like O1, it'll give you like a summary of what it did, but it's not a full chain of thought. And then other models, they'll just include like a real brief in the beginning introduction of what it did, but it's not a full COT.
Yeah, interestingly enough, I mean, far be it for me to kind of like almost like defend sort of OpenAI, but now it looked as if maybe the reason that they didn't kind of, as far as I'm aware, as Oracle didn't give the chain of the chain of reasoning, it just kind of gave the answer. It might have been because even if it gave the correct answer, if it showed if someone used the API and showed this reasoning, it might they might look at it and go, oh, it's rambling, or oh, it goes on tangents, and oh, it says it stated some fact that wasn't right, even though it didn't seem to affect the end result. They kind of start losing trust in it. So I think it might have been that rather than just wanting to be sort of really secretive, and really kind of standoffish or something like that.
So we're close to the top of the hour. If we've got any quick questions or topic people want to talk about today, and then we can talk about what we want to do next week.
Okay.
Are we moving on to something else next week, or are we continuing this? I mean, it's fine either way, because it's kind of I just noticed we hadn't done. There's other things like other kind of innovations, like was it the multi-head latent attention, or the kind of hard low-level coding? We may or may not.
No,
we may get to, or we may not. That's
Alan. That's actually that's actually what we're talking about. There's a number of innovations, either the innovations that they created or innovations that they borrowed from other sources, that were all targeted towards how do we do this more efficiently. And that's what we talked about in the smaller group. We had talked about maybe doing for next week, is covering some of those. Ted has a really good presentations put together. And Ted, I don't know if you'd rather just replay that or just go through the slides again on your MHA.
Maybe, yeah, it might be easy enough to play the video, but we have the advantage that if people have questions, we can pause and talk about stuff.
That takes less prep on your time, probably. So I think that's where we're steering towards then. So there's the I haven't so the multi-head latent attention is to me look like one of the key things that allowed them to get a higher performance. There's the what are the other ones? The multi-token prediction, the 8-bit was a really interesting one. Again, I don't think they innovated that, but they applied it. And I don't know if I haven't heard of somebody using 8-bit training elsewhere. So it's one of those things where one of the watershed, Sally, that you talk about this being an important paper. To me, what it seems like it's brought, like ChatGPT brought generative models to the public attention. Here, it seems like what is being brought to the public attention is efficiency, and it seems like I've felt like these big companies are just throwing tons and tons of dollars without really changing the core that they're working on. And this is one of the first examples where it really did focus on efficiency, and now people are aware of that. So that's the part I liked about it.
Even though the efficiency is sort of forced upon them by certain resource restrictions and things like that.
Right. But it should be forced upon them anyhow because it's more cost effective. It's just I can't justify why they didn't. I mean, like I haven't found much on the what is it, dual pipe. I mean, they just spent a lot of full stack, from the framework clear down into the GPU programming. They paid a lot of attention to just how do we use this hardware efficiently. And the other players, to my knowledge, haven't been doing that.
I recall right before Grant left, one of the talks that we did was about the importance of speed and cost. Was that Grant that you did that, or that might have been somebody else that did that paper? But that was one of the last ones that I listened to about midway through last year. And I think it's a lost art, right? Because when you get 10x improvement, it turns out a whole lot of other shit you can spend your time and energy on,
and money.
Yeah. So I would definitely love to start crawling up the dependency tree.
Okay. We have a few hands raised, Roger.
Yeah. Aaron, should we let you jump in?
Alan was up first. He can go first ahead of me if you want.
Go for it.
Alan's had the mic a bit, so you go ahead.
Okay.
Yes.
So, I mean, I come from like a 90s hardware background originally, and then worked at Sun and then worked at Oracle, implementing, doing conformance, all that kind of stuff. And then I was sort of part of the, I call it like the Unix wars at the client side. And so I've just been questioning for a very long time this paradigm, and that the mainline AI providers backed by NVIDIA, I've said this, and of course everybody's been able to say, well, Trillions is getting, basically you're wrong because the brute force of markets, is sort of defining its own economics. And I was always sort of scratching my head saying, well, until someone does an incredibly brutal optimization, which was there's sort of a famous version of that workload in 2002, 2003. Anyone that likes to nerd out on that stuff can pick up. And it's the cost deltas, are all generally the same, somewhere between 10 and 50 to 1. That's usually kind of how they shake out. And a lot of it just comes down to, as you move up the hardware architecture, the complexity curve transforms so that it becomes multi-system complexity, right? Meaning like all the InfiniBand, like people don't realize like an InfiniBand connection is infinitely more expensive than an underlying server. And the only thing that's more expensive than that is a GPU. And so you just start, moving up this kind of absurd cost curve, which can just be optimized eventually by typically suboptimal designs, but it's like the 90-10 rule, right? If I can get you 90% of what you could get for 10% of the price, you're probably going to start well, let's put it this way. There is typically a large Gaussian distribution of your workload that makes sense
to go onto that isn't highest world-class, save the business authority that just run the business. And I feel like that's sort of where this is starting to shake out people's understanding from a paradigm. And the last quick point is, I remember we'll just say sort of oligopoly of high-end chips in the 90s, right? That Motorola had, Spark had, and they felt very much like NVIDIA, right? They kept putting larger and larger cluster groups, which then all that did is sort of push the complexity onto the software, which we got VM out of, which is not a bad thing. But then that forced this more complex virtualization. So I feel like this is something like that, like as a pattern. And it would be interesting to see the other providers, the open source ones, Mistral and Facebook and, others, to see if they really do roll your own, and then an existing one, and then maybe a hybrid one, and see, hey, what do we get when we start, we can make our own work together. And I think that's what we might see in the next, 30, 90 days. That will be really interesting. What's great about this, to be blunt, is the open source on the and I think the mistake people are focused on is like the software side. I'm focused on my bias, obviously, originally, where I felt I leaned back into that. Let's put it that way. And I just looked at the hardware architecture, and they bypassed the whole CUDA coding. I put a link in here, so they just went straight to the forced assembly in NVIDIA, which nobody does. Obviously, some nerds do that, but not anyone with a major AI model, because they just buy more H100 or just keep buying more, empty dump trucks. So I think this is what might be really interesting. And the last quick point is, Facebook has always been a really incredibly good hardware optimizer for decades now. I mean, back to the original web services, or web server days. So it'd be interesting to see how they kind of really bend into this optimization. So I just think that's where there could be just a lot of innovation here, in lots of models, right? Not like, laptop superpower model, desktop quadruple cluster model, whatever, N+1 models. So that's sort of my perspective. I put a bunch of links in for anyone that's likes the hardware refresher stuff. And I think that's an issue, is that very few
Brent,
people...
are you on the Slack? Would you mind popping those into the Slack so they don't disappear at the end of this?
Oh yeah, sure. Sorry about that. I'll just...
No, that's okay. Just I'm very interested to dig into that.
Yeah, and I think nobody pays attention to hardware. I mean, like, as when I came up, like you just had to learn, C shell and Born and like all this, like Unix scripting. And then you earned your way up the software stack or tech stack, and then from the hardware to the software. And I think everyone just sort of jumps past that now. And it'd be interesting to see how this shakes out, people having to go back to their original, Tannenbaum computer applications hardware books from the 90s and early 2000s, if any of you remember those. Anyway, so that was my little diatribe. And
Thanks,
once again,
Aaron.
thank you for this forum. It's really great.
Yeah, I think the interesting thing is that it's these guys didn't. It was software is what they did to make the equipment they already had more efficient. And it's like if companies are spending hundreds of millions of dollars on GPUs, why didn't somebody else think about how do I optimize the GPU streaming cores? And why did they invest in that?
They have no incentives. Actually, they had disincentives to do that.
Yep.
So it is any of the organizations which was resource constrained. For example, when all these big companies were throwing in GPUs and coming up with these bigger models, universities and researchers were struggling and figuring out how to keep pace and even innovate. And that's where they came up with these. As when I attended NeurIPS 2023, the advisor of people who invented Flash Attention and Mamba. And they said, well, all we had to do is to go back to database 101 and look at the system engineering that was going on. And with that simple trick on how to manipulate the memory and without loss of any accuracy, they got the self-attention working with 7-8 times cheaper memory load on the flow, and getting the performance 7-8 times more. I mean, the overall requirements remain the same, but just applying the systems engineering, and that's what these people also did. They It's very interesting. They actually borrowed the optimizations from a 2014 paper from a Stanford PhD who now works at NVIDIA on how to optimize and utilize these warps. Dedicate going below the CUDA level. So CUDA does not expose that level of control, if you may. So they went one level below to the assembly level, if you may, called PTX. And they said, okay, we'll allocate, in order to have a fully utilized pipeline, we will allocate some warps or the multiprocessing units, the SMs, for communication. And they came up with an exact number that they want to give for the given bandwidth and other configurations of the system. And the remaining for computation for your attention or whatever it was doing, or the number of MOE workers that they want to launch. And they came up with that exact math, I mean, kind of dynamic for each NVIDIA GPU and very specific to NVIDIA GPU in this case. But the point is that they went one level below, looked at something that was done a decade ago, and no one from these big companies would really bother about that. Yes, there is Triton and other things that came out so that there's more flexibility for people to work at the higher levels. But to Aaron and others who said they didn't have any incentive to do that at that point in time. And that's where, when you're resource crunched and constrained, I think a lot more innovations have come out from universities and now China.
And one other quick point on that is that the same thing happened in the Linux Unix wars, where everyone went to these insanely expensive buses, even by like today's standards, they were a fortune. And the Linux people went back to the NIC cards, which was already done. The work was done in the mid 90s on that, but there was no incentives. Actually, the incentives were perverse, which was the server companies selling more expensive clustering hardware as wraparounds in their server clusters. And so I think there's almost a similar dynamic here. The other piece I think is important is that we have to look at where the transformer model came from, which was Google, and what was their what was their true north, and what were the kind of data sets they were working with, which was their indexable, like that was their benchmark, right? Like something works effectively when we can prove it does search against the world far better. And then that became really the paradigm underneath everything else that we've been running for 7 years or 8 years.
All right. Well, let's see.
Alan has his hand up for a long time. Yeah.
Yeah, I was going to say, Alan.
I could, but it's probably. But I was. It could. I mean, it's relevant, but I think it might throw us on a bit of a like an even longer kind of discussion.
Can you hold
just
it to
very brief? I'll yeah. If I can make it next week, I'll
or the week after.
Just very briefly. I think it was about being far be it for me to defend kind of OpenAI on Anthropic or any other labs, but I felt that if your focus was on making more performant models in terms of benchmarks or real world situations, your focus would be on that, and optimization wouldn't necessarily be sort of a focus if that's what you're trying to do, come up with better and more powerful kind of optimizations, because it wouldn't make sense to sort of optimize an algorithm that you don't even know improves improves performance on this or that benchmark. But I think that could have been like a whole other discussion of itself.
Okay, well let's we can, Alan, if you want to bring that up next week, we can spend some time on that as well. But we probably should go ahead and stop the recording for this.